The presentation?
Yeah, I will just do it. All right, folks, let's start this part about the LNG calculation. Very briefly, this is a very short. Can you all see it? Okay. So we have touched this thing on our first day when we are talking about the. So it is the market consumption measurement and calculation. This is what we are going to do. This, you remember, I've shown you on the first day where we have got this methane. Every different LNGs, like every finger of us has got a different fingerprint. Whatever we produce in at one time in one refinery or one liquefaction plant, it will be different to the one which we. So normally, as a general rule, Ras-Laffan has got a 90% methane, 6% ethane, propane, butane, and this is Das Island, and this is the standard. So normally the density of it is about 0.46, and the carriage temperature could be different because we call them impurities. We prefer to have pure methane molecules in it, mole fraction, but unfortunately the cost of removing these things is very, very high. So sometimes these impurities are there. We are going to consume it, so we do not want it to be. But this is what is affecting in your engine combustion. For example, if you have got high number of moles of propane and ethane, your piston is going up. Their ignition point is different. So they will ignite and they will not let the piston to go up properly and get the real combustion at the right timing. So that will create a knocking in your engine. This is not an engineer speaking. So that creates a knocking, and that knocking is more because of the impurities. So we want the pure thing to be delivered to us, but we normally sometimes we do not have the choice. But the good thing is that when the cargo is vaporizing from the tank, full tank, then mostly the methane molecules are the first one which leaves, because methane boiling point is roughly minus 160-degree temperature. So they will just run out first, and most of the time for your engine combustion you get better quality of these things. But we have got the others also, the impurities also. So increment of gas LNG production, this is just to give you a touch. The coal is fairly steady. Natural gas, can you see how many millions of tons has been increased from 1980 to 2035? This, at the moment, we are somewhere here with with regard to the hydrocarbon, somewhere here, but it is going to be natural gas here, and some time later we are going to go very high. Okay, and of course there is a saying that nuclear might be a very good alternative, but in current political situation or security situation, that can't happen. So this is the LNG environment band traditional engine. We have got these figures, emissions across the engines. Low sulfur fuel, we have got this kind of and heavy fuel oil, this kind, of course, and this. So we want to reduce the NOx, we want to reduce the carbons, and we want to reduce the SOx and the particulate matter. The good thing is in LNG fuel, these things are very less. Can you see? And most of it is just NOx and little bit of carbon dioxide. No particulate matter, no SOx. Okay, so there are three main markets again. Henry Hub, a distribution for natural gas pipelines, Louisiana, owned by SEP Pipeline, LLC. Why we are giving you this information? So that it is food for thought. When you go back, you are going back to go to the websites of these. You can note down their names, and you can go to their websites and see what it's going on. Because understanding LNG, because we are talking about LNG calculation, and why we are doing this calculation is for buying and selling, isn't it? Or bunker is all about, buying and selling. There is, touch wood, there is very less monkey business in LNG bunkering as compared to the other few. So the pricing point of a natural gas future contract traded in New York, which is mercantile exchange, we normally refer it as NYMEX. If you Google NYMEX, you will be able to get this. And the OTC swaps traded on Continental Exchange, Intercontinental Exchange, which called ICE. Okay, so normally we refer it as ICE, NYMEX, and of course Henry Hub as the HH. Henry Hub is a USA one. In UK, for Europe, we have got the NBP. It is not a physical Baltic exchange or anything like that. It is a virtual trading location for the sale and purchase of exchange of natural gas. We have got Southwark terminal in UK, and there are other terminals in UK, Grain terminal, etc., etc., which is dealing with all these things. So, London they have. Where it is a virtual trading location, but this is called London Market. NBP UK, Henry Hub UK. Even the Henry Hub is more or less virtual. You go on the internet and you trade because Baltic Exchange has gone electronic now, over a decade now. So early there is no physical market where we go and exchange commodity. So it is all electronic. So the pricing of delivery point for the ICE future Europe's intercontinental exchange or future contracts. Normally the gas is sold in advance, even before it is liquefied. So we say it's future commodities. Japan custom cleared crude JCC market. The average price of custom cleared crude imports into Japan commonly use index for long-term LNG contracts in Japan, Korea, and Taiwan in the Far East. This is called linking with the oil price. So far, the industry is keeping itself keeping it aligned with the LNG, with the oil market. But now the LNG is trying to develop its own identity as the market because it is growing now. So, and of course, we are selling it and buying it not in liters or tons. We buy and sell it because of its calorific value. We call it MMBTU. BTU, British Thermal Units, and this is so LNG is traded on energy content, what it has. The more impurities, the lesser MMBTU, millions of British thermal unit. 1 cubic meter of natural gas is equal to roughly 0.0392 MMBTU. Again, it varies with the quality of LNG. 1 cubic meter of LNG is 23.9 MMBTU roughly. So you can see 1 cubic meter of natural gas, NG, which is coming into our pipelines at home. But when you convert it to LNG, it is rather than 0.0392, it is 23. Because what we have done, we have condensed it to 600 times of its volume. So technically it is equivalent 1 cubic meter of LNG is equivalent to 600 roughly cubic meters of natural gas. Okay. So 1 MMBTU could heat, this is just for your knowledge, 2519 hydrox water from 0 to 100 degrees. centigrade, and 1 cubic meter of LNG, which is 23.9 million BTU, could heat 23.9 into 2519, which is 60,204 liter of water from 0 to 100 degrees. So over 60 tons of water you can heat with the 1 cubic meter of LNG from 0. And of course, it is all specific heat. We are not talking about any latent heat. Okay? Are we happy? This is just to give you the understanding of the unit. Unless you understand the unit, you cannot, calculate it, buy it, sell it, or use it in your engine room, or on board your vessel, or you supply as a bunker to another vessel. So a BTU, I'm just explaining. Those of you who are naval architect engineers, you already know what is BTU. The amount of heat needed to raise 1 pound of water by just 1 degree Fahrenheit, which is equal roughly to 1055 joules or to 52 calories. Okay. I suggest please note it down, because this is where this conversion you will, all of you, can you note it down please? Happy? This is courtesy to Energy Information Agency. That is the source for this thing. We are now talking about the efficiency, fuel efficiency in kilowatts per hour per pound. Wood has got this, coal has got this kilowatt per hour for heating efficiency. Propane has this much, oil has this much. So natural gas is slightly higher than oil. And of course, both heating efficiency and kilowatt per hour per pound. So that's why we are very happy that this thing is cheap enough. It is available in abundance. There is a rough estimation. Of course, don't quote me. It is going to be for a couple of 100 years. It is available. But of course, the world or the experts are trying to find another alternatives now. Okay, so LNG content, can you note down this also? This is giving a comparative analysis. Now, two things which, because we are comparing, you as an engineer also want to compare, or naval architect want to compare it. It is, for example, LNG has got a 53.6 megajoules, MDA has got the first per kilogram, of course. MDO has got 45.2 and HFO has got 42.9. So it has got more energy here, because you remember we have reduced it to 600 times of its volume. 600 cubic meter, which is equal to the size of this building. We can shrink it down to just 1 cubic meter, which we can carry in our suitcases, isn't it? So that is the amount. And now we are doing the comparative analysis of fuel oil or flash points. HFO need to go to over 60 degree to flash. Marine diesel oil, again about plus 60 degree. But LNG, can you see, minus 188 is the flash point. So flashing is not a problem. You can use in spark ignition engines. You can even blend it with other fuels to burn it in the engines. So this is the volumetric comparison. 1.8 times of the volume of LNG, and MDO is 1.7 times the volume of LNG. Okay, so this is the volumetric comparison for our bunker bars, bunker tanks on board the ship. Again, various LNGs have different identities, which I have already discussed with you. And of course, methane number. That is one important thing for you as an engineer. Provides indication of knock tendency. Pure methane is going to be 100 per methane number. So if you are taking a bunker, or if you are giving a bunker to someone, they will be more interested in the methane number. How many moles of methane are there, or how much is the impurity, isn't it? Are you getting me? Right. So pure ethane has got 44 moles and 44 methane number, and pure propane. So if we contaminate this one with it, of course this number will not be there. So number varies depending on the composition of LNG. So the methane number will be the final number, putting it all together. There may be some butane molecules. Okay. So knocking. This is what you as an engineer will be more interested. That is why I want you to, please feel free to ask me questions. So affects low pressure 4-stroke engine normally. Not smooth combustion in cylindrical chamber. Continuous combustion ahead of the front flame means I've already explained you that normal combustion, spark, and this is normal. But slightly ahead of the built up of maximum pressure, there will be a knock. Okay, slight knock. This is a very slight knock, and this is an intense knock. And if the knocking is more vibration, the stresses on the engines, the exhaust temperature management will be difficult, and all these kind of things. Okay, so methane number. If a gas mixture has a methane number of 80, its knock resistance is equivalent to that of gas comprised of 80% methane and 20% hydrogen. Okay, it is as simple as that. There are gas constituents which have a higher methane number than 100. Therefore, it is also possible for a gas composite to have a higher methane number than 100. That is also, mind that it is not percentage. It is the moles or the molecules or number. Okay. Now, LNG behavior. This is very important thing, especially for purging the tanks or managing for bunkers and etc. LNG behavior. LNG, can you see the minus 100 degree? If the room temperature here is minus 100 degree, I will find the LNG suspended in the middle, anywhere. If I release the LNG here, it will stay here. It will be suspended because it is the same density as the air, neither heavier nor lighter. And if it is going to be, say, minus 90, it is going to go up. So it is lighter than air. You remember what is nail?
Nitrogen.
Nitrogen.
L is LNG.
LPGs. Nitrogen, air, inert, and LPGs. And methane is sometime on the top or at the bottom. If it is in this state, it is on the top. If it is in this state, it is at the bottom. Okay, so above minus 100 degree, it is lighter than air. Below minus 100 degree, it is heavier than. So ratio is the density of methane vapor or density of the. Then note it down. And density of air assumed to be 1.27 kilogram per cubic meter.
Can I ask you?
Yes, please.
If this one, if the engine, propulsion engine is running on, will it require more maintenance as compared to HF?
No. LNG engines require lesser maintenance. Of course, the lubrication oil is the most important thing there. And if you are running at the right temperature, technically you can open your cylinder head or valves, and there's not a single drop of carbon in it. You remember on the first day we have shown you a video, which if you burn a candle and you put it on top of the uh, glass beaker glass, your glass will become black. Even with diesel oil or even with petrol, it will leave some carbon on the glass. But if you burn the LNG on top of the glass, this glass will never get a single drop of carbon on it. It is how clean it is. So technically, if you open the engines after say 5,000 running hours or 10,000 or 1,000 running hours, it will be squeaky clean if it is using the methane of good quality, or LNG of good quality. Even the propane and butane does not have so much of carbon, because technically it is the impurities which mercury, sulfur, carbon itself is giving it a bad shape. If we have got less of that, then it is better for us. Okay. So let's move on. We are talking about the LNG behavior and density shift. We have already talked earlier about the roll off and all that kind of thing. So yeah, feel free. Energy density is 2.53 times more than CNG, 9 megajoules per liter. And about 60% of gasoline, diesel. So technically that is equal density of this. So in liquid phase, this is the LNG at 1 bar pressure and minus 163 degree centigrade. Then we have got LNG at 3 bar pressure, minus 1 degree centigrade. And this is the saturated LNG at 8 bar, minus 1. Okay, and of course everything here is the liquid phase, everything here is the gas. So this is where we are showing you the relationship between the pressure and the temperature. So if the temperature is Charles' law, you have done it. High temperature, high pressure. So this is what we are trying to achieve. We are trying to give it this. The module 2, prepared by the World Maritime University, has addressed these things very well, and I will ask you to have an access to those things if they allow. So LNG value for combustion. This is also one of the parameter in the bunkering. What is the value? If I'm, fuel oil bunker and all that, you send it to lab for taking the quality. Do you get every port the same quality bunker? No. Yeah, it is. Some of them has got a higher sulfur content, some less sulfur content. But mind that the more impurities you remove, the more expensive it is going to become, isn't it? So LNG quality is dependent on several aspects. There needs to be a balance in order to ensure LNG. Of course, bunker is value for money and proper operation of the engine. It is a very fine balance. You do not want to say, if you have a pet, you don't want to feed him or her the cold biscuits, because it will not be worth. So you will have to decide what you can, what is better for you. Although, so LNG will be traded in energy content, BTU. Change in composition will affect. If you change the temperature, the density, energy content, methane number, and above all, the price. Okay, so at the moment, most of the supplier are getting the bunker supply from one. For example, one has got a source from Qatar. Mm. So they will be just selling the Qatar petrol. But nowadays, since the LNG is now going also in kind of open market trading or not the long term, for example, the Rotterdam port, they have got a bunkering system. But Rotterdam port is getting the LNG. One ship is coming from Qatar, the other may be coming from Algeria, the third may be coming from Boni terminal in Nigeria, and you name it. So now all the qualities of this is different, and they will be settling down in different tanks. They will be supplied to your bunker barge or to you as a ship with all these variables: temperature, density, methane number, and price is normally determined by brokers.
Linked to crude oil price.
At the moment, it is fairly linked to crude oil price. Let me be honest. But what they are trying now to do is to make it more independent of the bunker price. As soon as the real bunker market for LNG is established, which is happening, because it is again supply and demand. LNG, which would have been shot up very fast earlier, because this was considered as fuel of the future by many of the world. But suddenly the oil prices has gone down. So the difference between the price of LNG and marine diesel oil has become so less. So the ship owners does not want to, lose their space for bunker tanks, new bunker tanks or LNG tanks. And also they do not want to convert their engines for dual fuel, because existing engines can be converted to dual fuel, but it is all costing money. Or some may decide, okay, we'll put a totally new dual fuel engine. In fact, whatever we call dual fuel engine are mostly tri-fuel engines. They can burn heavy fuel oil, diesel oil, marine diesel oil, and of course this thing. So, did I answer your question?
Yes,
sir.
Oh,
and
yeah.
who are the largest producers for LNG?
Qatar.
Oh, and yeah, Qatar is one of the largest producer, but it is changing. It is going to change. It is going to change. At the moment, the America is importing, or Algeria, from Algeria, there are lots going to America. But in future, America is going to be one of the biggest exporter of LNG. We have got huge reserves in the North Pole areas. We have got very big reserves in the Central Asian states. This is where the lines were planned to come. Iran has got a lot of reserves, which you remember the line from Iran, Pakistan, and India. So, and of course, Qatar is one of the one. Qatar has got a very good, huge LNG liquefaction plant, so they can do a lot about it. They have got their own vessels, mostly Q-Flex, Q-Max, and all that. Nigeria is one of the exporter of it. Algeria is one of the oldest exporter of, Brunei, Far East. Oh, there are huge reserves over there. But now there's one ship which is recently launched, and it is able to transport CNG, compressed natural gas. So yes, it is at the moment we are going through this transformation phase, and you folks are the one which are at the better point.
And Saudi Arabia is not one of the major.
Saudi Arabia is also one of the exporter, but Saudi Arabia is more focused on oil. Their Arabian heavy, Arabian light, I mean the Yanbu crude and all that, they are much in demand. So, but nowadays gas is found almost everywhere.
And pardon my ignorance, so what is shale gas?
Shale gas is the method where we'll be going down and we are fracking, and there are so many methods of extracting the gas from the earth. The gas is trapped in different, land under earth layers. So even fracking we can do coal. We are not using coal, but coal is also a hydrocarbon, solid form of hydrocarbon. So we can extract the gas from the coal. So there are so many processes which is beyond the scope of this training. So I'm sorry, but I mean in the evening or afternoon later in the breaks I can explain you that. So don't worry about it. So atmospheric tank filling limit, our maximum tank pressure of 0.7 bar gauge, not absolute, bar gauge. Reference, do you know the difference between the absolute pressure and gauge pressure? Can you explain it?
So the absolute pressure is the gauge pressure, and add to it the atmospheric.
The absolute pressure is the atmospheric pressure plus the gauge pressure.
Yes, sir.
Reference temperature is SVP of 0.7 bar is 148 degree. This is where we are showing you the calculation. Density of reference temperature is minus 154 degree, and the energy is going to be it is going to be 412.4 kilogram per cubic meter. So for example, now loading temperature minus 159, the density is 418 kilogram, and FL is equal to be 0.98, which is 96. We are talking about the filling limits. So if you have got the higher the density, then we will be able to decide the filling limit. Remember, the ship we can, or tank, if it is in a spherical tank, we can fill it up to 99.5%. It is not like oil tankers where your maximum limit is 98% filling. No. It depends on the shape of the tank, the density of the vessel. So here we have got a minus 155 degree temperature and 412 density. We can do it, fill it to 97.9%. Okay, so that was an atmospheric tank filling. But now we talk about the pressure tank filling limits, which is maximum tank pressures. For example, 10 bar gauge. Your bunker tank, which I have shown you in the movie this morning, which is and reference temperature is SVP of 10 bar gauge and minus 121.9 degrees centigrade. So the pressurized tank, did you notice we cannot make it full? We can make it 83.2% because we need some also room for it. Okay, and of course 98% filling. That is the constant. 98 is the reference point. So this is the comparison. You go through this yourself, and so that you can make a comparison yourself. And read the note at the bottom. Pressure tank loads 13.9 less than equivalent size atmospheric tank, because earlier on we were always thinking bunker tanks, pressurized tank, okay, bullet tanks, type tank. But now the industry is saying, because it has a lot of broken space, wasted space, why not convert your certain areas and give it the shape of, now the membrane tanks are more coming on these vessels as the bunker tanks. So read it. Happy?
Yes.
These are some examples of how much you can load on different loading temperatures. Mind that on pressurized vessel, you may notice that we can even load at a higher temperature, because it is just the pressure. A higher temperature, higher pressure. Okay? Happy? So this is the formula. Can you please note it down and also note down this thing. Loading limit is the maximum allowable liquid vapor volume relative to tank volume to which tank may be loaded. It is very important for you. Happy? Yes. So here we go. This is a couple of things which I just want to show you, which you will come across on board your vessel, which is the coriospheres enter the sensors, and this creates the vibration, and we measure the flow offline. So sometime rather than just measuring the liquid volume, we are also measuring the flow, how the flow is going on it. And of course, density measurement is based on the natural frequency. So if there is no flow, there will be no change in frequency. If there is flow, then there will be change in the frequency. So flow gauge are different, and some of them are Doppler meter type, which is transmitter and receivers. And then we have got flow gauge, which are also turbine type, where you are moving turbines to get it is a rotor is moving, and the motion of the rotor is giving you the flow gauge or flow turbine flow position. This is what you are also learned on the loadicator exercises when we have done. You have seen on that, and in some of it you will also do it in the module 4 when we are talking about the stability of the vessel. So that is it. So calculated density of the LNG loaded. The density of LNG which you are loading is measured in kilogram per cubic meter. And of course, this calculation is based on the composition of LNG loaded in mole percent as a fixed temperature, say -161, taking into account the molar mass of each component as defined in the standard, which is ISO 6976. Happy? So, of course, the molar volume of each component, the correction of factors are K1, K2 as described in the revised called McKinley calculation method. Folks, I've given you just as a fruit of thought. The scope of this module is not, to go in and describe each method for calculations, but you have got, and you'll find the information in different books and in on internet as well. So the calculation of gross unloaded or reloaded energy is ELNG, in fraction of VLNG, volume of LNG unloaded or reloaded by the barge, and PLNG, density of LNG unloaded or reloaded. HLNG is the gross heating value on mass basis of the LNG reloaded. So that is E value of a LNG. Yeah. So VLNG into PLNG and HLNG. So that is the formula. So folks, we will now go for the simulator exercise for our. Okay, we'll take a few minutes break and then we will go for the exercise. Thank you. Do you have any questions? No. Okay. Can we say bye to our virtual learner for the while, because we are doing the simulator exercise, okay, which is on the loadicator, which cannot be